Okay, now we're going. Okay, so is there go with the fire art problem? You get $700 at 4% interest and $800 at 2% interest, right? Okay, good. So last topic, last sub lesson for this topic, and then we're in Unit 4 for the rest of the year. Okay, so Unit 3 is really quick. All right, but this is it. So how do we solve this system? Okay, it's a system of inequalities. So what I want you guys to do for me is determine how you solve this system, okay? And just talk about it with your group mates for a couple of minutes and come up with some strategies that might work, all right? And we'll go from there.
Do you know how to solve the following system?
Try some things. Try some things.
Ma, do you know how to solve the following system?
Wait, can you use elimination?
I don't know, can you use
Or
exact same like,
No, no,
like, just,
hey,
I solved it. Yeah, just solve it like you solved it. You can put the x plus 4 instead of y, right? And then you can solve for x.
It's just a problem.
No, it's still elimination.
It's not an equal sign, so that.
Why elimination when you
There's
solve it?
negative x and negative x.
There's already solved. Yeah, negative x, you would have to multiply negative one of the negative x, like one side one. It doesn't have to be negative positive, but it's already solved for it. Don't put it.
I think you can do a
Greater than
So this is dropping.
This
This is dropping.
We're asking conversation at the bottom of my.
Well, I did, I feel like two looks. You do that.
your water bottle.
Okay.
You just need to get rid of that plus 4 that's attached to the negative.
Okay.
And you stop talking and then you get negative 8.
Both sides, then you end up with that.
That's see that I think it would be something.
I think it would be
Wait.
something like this. I honestly have no idea.
I don't know about that.
So the solved equation 1 for y.
I know.
No, because we can put less than.
Y is greater than or you get to negative x.
I got negative 4 and positive 4.
No,
So
yeah, you can do less than. But you then your answer would be.
I think it's 4.
What is it? It doesn't even say what it says
This is negative 4.
So
I also got
go up
one.
to be negative 3.
I got this. But I don't know why I saw it.
Person, I'm using the first case for everybody else.
I can do elimination. I don't know.
Oh my.
You could do elimination if you want. You don't have to do
Yeah, I know. Why are you showing me why?
Because you have to solve the line x.
Whatever.
Whatever.
Exactly.
Oh, well, okay.
Okay, all right. All right, so I've heard good dialogue, which is wonderful. So now I want you guys to transfer what you guys talked about in your groups. To me, can you give me a brief summary, okay, of what you guys discussed? A quick summary, okay? All right. What did you guys discuss up here in the red group?
We were discussing like how to solve it, and
Wonderful.
I chose substitution.
You chose substitution, okay? So, take me through your process, please.
So first I replaced the y in negative x plus 3y with x minus 4. So I got negative x plus 3y times x minus 4, which should give us negative x plus 3x minus 12 is less than 12. And then it would be 2x minus 12 is less than 12. And then you have the 12 to both sides, which would be 2x less than 24. Then you just divide the 2x and 24 by 2 and you get x equals less than 12.
Okay, now I have a question for you. Okay, I got a question for you. Just a minute, I have a question. Up here, equation 2 says y is greater than or equal to negative x plus 4. So I have a question. Are you allowed then, since this doesn't say y equals, are you allowed to replace y with an expression that where it says it's greater than or equal to?
Yes. Question mark?
I don't think that, I'm asking a question here. I'm asking.
No. I don't know.
I don't know
Wait,
if you're
I
allowed
think-
to.
Yes, because we also have the
don't
option
think you
for it
would.
to be
You wanna know what I did?
I mean, if it was an equal to down there, if it was y equals, I'd be perfectly fine with what you said. But I'm questioning whether or not if it's greater than or equal to, if that has any effect on the outcome of what your values are. For x and y. Okay? Anybody else have any ideas?
I think that you could like cancel them out.
Okay, do tell. How so?
I don't know. I think you could like, since like, I think one could be like greater than the other one, so it cancels out.
Okay, all right. So can you give me a little bit more to work on here so I can kind of follow you here?
Never mind.
You don't have to, you don't have to quit. I just want to try to follow along with what you're saying. Don't give up on it.
I give up.
No, don't give up. But would you like to hand it off to somebody else?
Who is there to hand it off?
Morena's willing to help out here. Is that
You
okay?
can call that Morena.
All right, Morena, help me out here. What are you thinking?
I was saying that since this one is less than, and this one is, the other one is greater than or equal to, the less than and greater than cancel out and it just equals. Since you know how this one is greater than or equal.
So you think the signs cancel out because one's one way, one's the other way?
That's
You don't know,
exactly
that's
what
just
I was
what you
thinking
thought?
too.
You thought the same thing? Okay,
Well,
all right.
also, I was also thinking that since 3y is like greater than y, like it could like, since they're both right next to the sign, they could like kind of pull the sign with it and cancel out.
Okay. Jack, what do you think over here?
You can multiply the first equation,
Okay,
And then you get x plus, well, x minus 3y is greater than 12. You get both sign.
okay.
And then once you cancel out, you get 2y is greater than or equal to negative
We're gonna be negative 2, 1.
no, it'd
8.
be
No,
positive.
Wait, to multiply by negative 1, you gotta multiply every term by negative 1, right?
You can multiply the second equation.
Okay, just multiply one term here.
I think I did it wrong, but when you divide by like a negative, exponent or whatever, like this sign flips, right?
If we're in inequality, you can multiply or divide by a negative number to get the variable by itself.
So would that work?
You have to reverse the symbol.
So like you could like reverse the first symbol. and
If
then
you multiply everything by the same negative number, or divide by the same negative number, yes.
Yeah.
Okay. All right. I sense we're hitting some roadblocks here. Am I sensing this correctly or no? We kind of shut down about every single possibility here, and we're not sure about some other possibilities, right? Okay. Ryan?
I don't know, I was just looking at it, this is just kind of like a guess. But if you could take negative x plus 4 and put it in the place of the 3y, and then you would get the negative x, and then the plus, with the parentheses, negative x plus 4, and then when you multiply the two x's, like you would have to, they would cancel out and become a single x, because it would be like 1 times 1. So it would become positive 1x or positive x. And then you get the plus 4, and it would just be like x plus 4 is less than 12, and then you would just solve based off of there.
Okay, I'm gonna run the same thing. Marat suggested this from the very beginning. Okay. So I'm gonna ask you the same question that I asked Tim. Okay. Here's the thing. This doesn't say y equals negative x plus 4. This says y is greater than or equal to negative x plus 4. Is it still okay to substitute this expression in for y when y doesn't necessarily equal that expression in terms of x? That's what we're asking here. And that's what we're trying to figure out.
What?
Okay? Is that still allowed?
It's not.
Is that still allowed? That's what we have to talk about here. Okay? Natalie, then Indy, then we're gonna have to move on.
So what I did is I solved one for y, like get the y's on the same side,
Okay?
and then I multiplied the top equation by 3 because there's a fraction,
Mm-hmm.
and then I canceled out the x's, and then I stuck it.
So what'd you get? You got stuck there?
Yeah.
Okay.
Wait, how did you get a fraction?
Well, when I solved the equation for y.
Okay, Indy, you wanna say something real fast?
Are you allowed to do an equation, or not an equation, a graph, because one of them's slope intercept and the other is standard?
Did I ever rule out anything about the way of the graphing method?
No.
Didn't everybody just forget about the graphing method?
The graphing method?
What's
I
that?
mean, when we did an inequality before, like this, a linear inequality, to figure out where the solution was, and we have to graph the solution on the plane, figure out where it was.
I just don't know how it works.
I don't remember it.
I think you could graph it because like you know how when we had to do that one graph thing and it gave you two equations or two inequalities and you had to like put the two dots on it. Connect them.
Hey everybody, just here's food for thought. Unlike a system of equations where there are three methods, graphing, substitution, elimination, for a system of inequalities, there's only one method.
Graphing.
Right.
Nailed it.
Okay. Yeah. You have no choice because here's what's going to happen. I saw a lot of you guys get the answer y is less than or equal to or greater than 4 or negative 4, right? Okay. Well, how do you plug that in for y and get a value for x? If y can be infinitely many things, right? If you're saying that y is greater than or equal to negative 4, then you can do negative 3, you can do negative 1, you can do 4, you can do 8, you can do a whole bunch of different things. How do you know which one is correct for x? You don't.
You don't.
Okay? Or you have a lot of solutions for x, and that becomes a problem too, because then you know where the limit is, right? So the best way to get these things figured out is by graphing. Okay? You graph inequality 1. You're going to graph inequality 2. And I'm going to show you what happens when you do this.
Oh, I forgot.
Okay? So let's get going here. But yes, don't forget graphing. I know we've talked about graphing is not very feasible right now for us a lot of time with those equations, right? Because it's tedious and hard to do. Okay? But for inequalities, everybody, unfortunately, we don't have any other choice. If we want to account for all solutions for our inequalities, we have to graph the system. Okay? Then we can get a better idea of what's happening here and how this is working out. So you're going to graph inequality 1, and then we'll go from there, all right? So I have this right here ready to go. So I'm going to write these down again. So equation 1 is negative x plus 3y is less than 12. And equation 2 is y is greater than or equal to negative x plus 4. Let's bring it down here, and let's get going here, okay? So for inequality 1, I'm going to solve this for y. Everybody okay with that? Get it in graphing form. So we're going to add x to each side. So I get 3y is less than or equal to x plus 12. Divide everything by 3. And I get y is less than or equal to 1/3 x plus 4. Okay, everybody good with that? Okay. Wasn't it less than the original problem? On the top, is it not? Equation 1.
Less than. It is
Look
less
at the
than,
symbol.
not even.
Right. It's not here either on this one. Right. The signs match up, right? Right here and here.
Yeah, but you were with the answer.
Oh, and the answer I did. Okay, I'll fix it. No problem. Yeah, that still doesn't make a difference. Okay, I divide by positive numbers, so it doesn't change anything. Okay.
Wouldn't you like use the other graphics? Could you
What other graphic style?
like the straight line with like the just a line, and then it has like the two arrows on the side, and like dash 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 dash.
We're gonna be doing something like that, perhaps. Yeah. Sorry, Michael. Thanks for catching that. I forgot. Your slope is 1/3. Your intercept is 0,4. I'm going to move these over here to the other side so I don't have them in the middle of the graph there. We're going to start at 0,4. 1, 2, 3, 4. Let's be right there. Okay. And I'm going to go up 1 and 3 over. I'm going to go down 1 for my y-intercept, down 1 and 3 to the left so I can just get another point for accuracy. Okay. Now, what kind of line is this? This is a little bit of review from first semester.
A positive linear.
It's a positive linear. It's a positive slope. That's correct. But is my boundary line going to be solid, or is it going to be dashed?
It's gonna be dashed.
You can remember why. Okay, Michael. Thanks for raising your hand.
If it's equal to, then it would be a straight line, but if it's 100% times, then it's done.
Good. Now, something that we might have forgotten over break. What side of this line do I shade?
You do 0, 0.
Okay. All right. Marina, thanks for raising your hand. How do you know for sure? I don't want I think. I want to know for sure. Okay. And I like to test 0, 0, which somebody else suggested as well. Okay. So plug it in here. You can plug it in here. You can plug it in here. It doesn't matter. So this is 0. This is 0. Is 0 less than 12? Yes, it is. So I'm going to shade below the line because 0, 0 is below the line. Okay. Does that make sense, everybody?
Yeah.
All right. So right up to your boundary line here. Like so. On down.
Oh.
Yeah, you need to get it all. Okay. I'll do this again. Try to get it a little bit better.
Wait, are we supposed to do this?
Yeah, shade it.
Wait, can I find like present here?
Wait, so the people like watching this can like see what you're doing?
Yep, they can see what I'm doing. They can't see you guys. They can just see my screen. So they can hear you.
Wait, your mic is muted.
No, my mic on my computer's muted. My mic on my
Can I
iPad is
take a
active.
picture? 'Cause I got kind of lost with the first part.
Yeah, just when I'm done.
And then we do the other one.
Wait, we have another one?
Yeah, there's 2.
Okay.
Wait, but didn't
No, I did not. We only graphed 1. Now you have to graph 2. Okay. So on number 2, it's already in slope-intercept form, so just graph it. Your slope is -1, right, over 1. Your intercept is 0, 4. Okay. You're going to start at 0, 4 again. Down 1, right 1. Right? Do it again. Is this a solid or dashed?
No, but I know it's solid because
Solid.
it's greater than. I mean,
Okay.
all equal to.
Okay. Now, we have to test 0, 0 again. Okay? So, 0 is here, 0 is here. Is 0 greater than or equal to 4? No, it is not. 0, 0 is here. So the solution zone is not on this side of the red line. It's on this side of the red line. Okay? Do you need me to go through that logic again?
No.
Okay, I'll do it one more time. We're testing 0, 0. 0, 0 is here. Plugging in the coordinates. 0 here, 0 here. okay? Or if I put it on the graph here, 0 here and 0 here, okay? So it becomes 0 greater than or equal to 4. Is this true or false? Since 0, 0 is here, the solution is on the other side of the line, right here.
Oh, so I just get another picture.
And this one's a straight line because it's
Yeah, because it's equal to.
That's correct. This one's a solid line because it's an equal to symbol. You're right.
Where the overlap is that answer?
Well, you're a little ahead of me here, Andy. Just a second. Okay? So, you might have noticed now these two lines divided your plane into 4 regions. One region is all red, one region is all blue, one region has no shading, one region has both shadings. Where's the solution?
In the purple.
Where the shadings intersect. Exactly. Okay? That's why I did red and blue, because red and blue make purple. And there is your solution.
They're kind of like gray.
Okay?
So,
Okay.
right, that
I mean, you can identify order pairs in it,
oh,
but how are you going to identify all the order pairs in it?
I see what you're saying.
Yeah, that's where the downfall is, guys. There's no really good way that you have at your disposal at this point in time, okay, to represent the solution zone that I just marked here on the graph using using an equation or the like. So we have to visually show the solution. Okay, Shelby. No, I'm sorry, Shelby. I did the same thing I did the other week. My apologies. I'm sorry.
Okay.
I'm looking at Michael's. Shelby sits in Michael's seat on the other day. I
Shelby,
apologize.
Oh my
Shelby
god.
Kite. Okay? You. Sophie. My
Well, I
mistake.
can't remember, but oh, I was gonna ask, how are you supposed to do this on a test? Like,
I'll have the plane for you.
do we
Yeah.
need markers?
You'll use colors. I'll have colored pencils for you,
Can we bring our own colored pencils?
if you wish. Preferably.
Want to.
That'd be nice if you could do that.
Okay.
Okay.
Colors we guys
So
choose.
you're not allowed to bring your own.
Okay?
Okay. Too bad.
I mean, that's as good as it's going to get.
It doesn't
Okay.
come out anymore because he's on
Old school.
Google Meet.
Googling.
I said Google Meet.
All right. So, here's the blowdown, guys. It's pretty straightforward. You graph and shade inequality 1. You graph and shade inequality 2. You identify where the solution zones of each one of those intersect, and that is your overall solution. Okay? That's it. All right? Think you can handle that? Okay. Let's try one here, and then we're going to move on. Okay?
What? I don't understand what you want.
Go ahead and give this one a try, everybody.
Only he understands muscle man.
Guys,
I mean, it's going to be probably early next week.
so like
I'm
the
the only
first
one who
Looking at
understands.
Wednesday.
Do you understand
This will
muscle
probably
man?
Wednesday.
Yeah, I think everyone
Right,
here
Capper,
does.
right.
I love muscle man.
Oh, chicken
Finish this up probably on Thursday.
You want it or not?
Maybe start around.
You're giving him
Serious
more.
about people could be just said that.
I want to do a word problem with this. I know that's what we're doing.
This is a lot easier now that we have the graph.
That's why I don't want you to roll it out.
And they can upset me.
All right. Guys, any graphs on this one, please? Okay. Our time is short. Graph and shade the first inequality. So Basically, this is what you were doing before break when you had the graph and inequality. Only now it's just two on the same plane. That's it. Okay? We're not changing the method. We're just putting two on the same plane and figuring where they intersect. Okay? That's all we're doing. No, you don't have to use red and blue. You can use whatever colors you wish. I don't have a problem with that. I'm not going to stick with red and blue because that way I'm consistent throughout. But you don't have to stick with red and blue. Okay? The key is also going to be red and blue, just FYI. Okay?
So since like y is negative, would you divide by negative to make it positive?
If that's the rule. Mm-hmm.
I don't remember.
It is the rule. That's negative 1. You don't forget about that's an inequality from that entails.
Oh yeah, so then you like flip the sign, make it around.
You remember some stuff from before, Sophie. Wonderful. Good
Yeah,
job.
it just takes like a little push.
Well, you know me, I'm good at pushing like that, okay? Yeah, I'm really good at motivating. That's why I get paid in class, really. That's why I get to enjoy my time with you guys every other day.
You enjoy your time with us?
I like my job.
Like, besides us, right?
No,
Besides the period members.
no.
No, besides.
There's some times where I might get a little annoyed with some of your decisions, but I really do appreciate you guys, and I appreciate your hard work, and I think we've gotten a lot done this year, despite all the obstacles that have come in our way. And that's to be committed.
You're adversity facers.
That's right.
What's adversity?
I don't know what that means.
Adversity.
I can't repeat.
Adversity, it really kind of like when you face adversity, you face like tough times or challenges ahead. Or,
How will the kids
that's
have
Well,
that?
right, that's our.
Wait, I have a question.
yes.
So like,
Maybe
how do we like do the 0, 0 test?
You just plug in 0, 0 for x and y. So
Oh,
so
Indeed,
0
I'm trying to
here,
learn.
0 there. So you're gonna get 0 here and 1. True or false?
true.
Okay.
False.
Well, which one is it?
I'm not-
Well, you have to put the logic. You have to do the logic then. Okay. I'm gonna get started on this one, everybody.
But then what if it is, then what side do you color?
Hold on. I'm gonna help you out with it. Okay, just a second.
I have left side and right
All right. So here's what we're going to do. We're gonna start at 0, 6. 1, 2, 3, 4, 5, 6. And next year, I'm gonna have better looking graphs. Sorry, guys. Yeah, well, I know you won't, but I know for me, I'm gonna have to have better, more accurate graph than this. I just did this freehand, and it's not the best.
The
So,
graph looks
1,
good to me.
2, 3, 4, 5. This is the dashed line, right, everybody?
They're both
Are they both dashed? Okay. Okay. All right. So, did I do something wrong? Oh, Nick got something else? Okay. So, question, is 0 less than 6? True or false? That is true. Okay. So 0, 0 is there, right? So I'm going to shade that side because 0, 0 was a solution.
The solution is at the top. The solution is at the very top. It's like a triangle.
Wait, why did we mark 0, 0?
We always test 0, 0.
Is this right?
Unless 0, 0 is on one of your boundary lines, you can test 0, 0.
Wait, show me yours. Did you get this? Wait, did
Oh
you
my
get
God,
this?
please find as many as
Can I see yours, Nick?
How many times am I?
What is that?
Not a lot of times.
I
Bueno.
Okay? So on the second one, I divide by -1 to get y by itself, and that means I have to do what with the symbol? Reverse. So I could get y is greater than 2x plus 1.
Wait, how did you get like a not straight line?
Pardon
Why
me?
didn't you get the red line?
Well, sweet, I haven't gotten the red line yet. I haven't graphed it, okay?
How did you get like
You're almost at your quota. What's up?
the like line? What? Oh wait, that never mind. That's,
You talk, what, you figured it out?
Yep.
Okay, that's good. I can do pretty good reading that kind of language, but I'm still a little rusty once in a while. Okay. That, huh. Okay. All right. We're going to start 0, 0, 0, 1. Right there. We're going to go up to right 1, right here. I believe this is also a dashed line. Is that correct? Let's see if I can get that just a little bit better here. There we go. Hey. Stay on task, please. All right. Now, shade what side? Okay. Is 0 less than -1? True or false? That is false. Okay. Okay. So 0, 0 is not a solution this time, so we shade the left side of the line.
so you just shade the left if it's wrong.
Mm-hmm. You shade the false. You shade the side that doesn't contain 0, 0 if it's wrong, if it's false.
But the blue one's right.
That's correct, because for the blue line, the blue inequality, 0, 0 was a solution.
Yeah, I took a guess.
Or don't guess.
Well, I didn't know.
Because it's not always going to be like.
Well, I asked, but the solution is.
Okay, and then you can outline your solution zone.
But wouldn't it be like kind of infinite, like for this side at least? Like infinite left side. I don't know how to explain it, but wouldn't it be like all this, but like less all this?
Oh yeah, this continues to extend beyond the graph. Yeah, we're just on the graph. We're just identifying it, outlining.
But it would be that way too.
Yeah, you have to go. Yeah, guys, when you graph your boundary line, it's real important. Like it was before, you have to extend it from one edge of your plane to the other edge. Okay, because you have to count for the entire solution zone. So your lines must touch opposite edges of your graph. Okay, opposite sides. Okay, every time. Okay, you can't bank on the fact that if you just stop it like right here, that you got everything accounted for, because you might just stop down here. Okay, so be careful. All right, but that's it. It's just this is just time consuming. Okay, basically. I mean, I think you guys know how to graph an inequality. You just got to do it twice now. There where they intersect.
Are we gonna have to do this for homework? Because I think
Yeah.
it's just time consuming.
Oh my
Yeah.
God.
So, I mean, you know that homework's always optional, but if you want to vary for it, you need to get it in.
It's
Okay? Fair enough. Always, but if you want to vary for it, you got to submit it.
If you don't want zero,
Holy.
Okay.
No, you don't get it.
All right,
It was
so.
so. I didn't have to get 0.5%.
Okay.
But
All right.
yeah, that's a lot.
So, whoa, my turn. Okay. So what we need to do on Thursday is we do another one of these just to practice, and I want to throw in maybe a word problem or two on this. Word problems, maybe a word problem understand it. Some inequality systems can have more than one inequality in them. That could be a little interesting little caveat that we need to talk about too. Okay, what that involves, and we could have some special equations too, like vertical and horizontal lines.
special.
So we got some things we still need to discuss then on Thursday about this. But you have enough info here now and a couple of examples to get you going on your assignment if you want to get a head start on it tomorrow.
Is it due tomorrow? Or
No, I put on there right now due tomorrow, but I'll make it due on Friday. That's okay. No problem with that. Okay? But it'll be in your best interest to get a head start tomorrow. Okay? Alrighty guys. Nice work today.